this is the book in PDF. But can you see my Google? Yeah.
Yes.
There's a lot of so this is the book, which is the one that is pinned on Slack, and this is the PDF version. Have you had the time? Did you?
I've looked through it before. Yeah.
Okay. So and I haven't just a quick look, and there is even this other website, R4 Psychological Science, and there's lots of things like core toolkits, getting started variables, and all these things, working with data, statistics, and many other things. So it's quite interesting. I didn't because I looked just at the markdown thing, and then this experiment thing as well. Many things, and all about how to get started, the data. Yeah.
Yeah, I think there were a few more resources that were generated based off of the original book. So I think that's where you come across the R for psychological science and answering questions with data. So yeah, I think there's a lot of good resources related to this content.
What is this Jamovi? And
I don't know that one.
And I'm not psychological.
Yeah.
Thing like researchers. I use data, but for different type of data. So not in particular for psychological research, and so I don't know what this CogStat as well, and this one here. So like quite new things for me. But this is the book down, which is quite the same as PDFs. And this answering question book, this is another one. So just to listen a bit more, we can use this what is this book down adaptation? Is that just as the same as the PDF? It looks like.
Yes, yeah, I think it's the same. It's just a different format, and I agree. I think that book down approach is probably the easiest to use.
Because I went through the PDF, which is quite the same. So they're not showing up.
You mean the rest of the cohort? They might show up.
Okay. Yes, what we did so far is like an introduction, and then we started with R, getting started with R, then the last session with Esmeralda, why do we learn statistics, which I joined later. And then it's this introduction about research design, which is quite interesting as well, even if it's general. But might help. So did you do the book already? This is what
I haven't done it completely. I started it, and then you know, just like so many things, it helps me to have a group doing it together to keep me on track. And so I was able to do a couple of chapters and then set it aside. But now that we have a group working on it, I'm able to stay a little bit more plugged in. So I'm hoping to get through it this time.
Yeah. I think it's about 15 past the hour, so we start.
Yeah.
Right? Shall we
Yeah.
start?
Yep, go for it.
Yeah. Okay. So this is a chapter about research design, and it talks. It goes through all the things that you need to think about when you want to do a research. And so designing your research is a very important step. And I go back to the PDF because this is what I found. So I selected a few things from here. And this book is mainly on psychological research. So it throws you the lines, and the case studies are about psychological case studies. But not only that, because it provides examples on other things, just to give you an idea of how to use this various type of data, and to how to make research on different type of data, as well as not only that. So I can say basically when the research design is a very important step, and it should be like the first step that you do when you work on a research question. And so if you do psychological measurements, and so you want to answer a sort of psychological answer, you are going to measure something which is about human behavior. So this is the case that when you need to define the type of measurements that you are going to use. So when obviously you need to assign numbers of labels to describe your data, and define which one are the important ones for answering your research question, and what are the less informative. So it provides some examples on the type of data that you might have. So, for example, my age is 33 years. So the age would be the variable, and the 33 years is the measurements. And so the things to be measured, and the measurements in itself. So this contains is the vector that contains all the measurements, and it is so like a bucket of things that you are going to measure, and this is the result of, so it's one of the measures. There are depending on the type of research question that you want to answer, there might be some conventions which are defined as a measure conventions. So you they might relate to how the variable is defined. If you are talking about time, or other type of variables, so that there are social conventions that are usually need to be considered. So it's not that you so you base your predictor adjustments on conventions, basically. So For example, if you are analyzing data which contains ages for, I don't know, smoking men and the risk for them to get into health issues, you might use the age as a variable, so like the number of years or the years in itself. Why, if you are studying at birth level, so you don't have the years as a measurement, but you have a different type of. So you need to consider what are you going to measure basically, and use the conventions that are normally so conventionally used. Then there is a measurement method when you do basically set up you have your research question, and then you want to think about what type of methodology you are going to use for answer this question. And there are some measurements methods that are conventionally used. So if you, there are some examples, but so in briefly, what it's my important to think is what you are going to answer and what do you need to answer this question, and how your variables, so both the response that you are going to set, and this will be the variable that will you are measuring. You have the observations already, but you want to see if something changes, how, and this measurement can change. These measurements can change. So you think about all those things, and then you make adjustments based on conventions that are already made, such as transforming your data if you have daytime years, months, or they are characters, you transform in date, and those things. When this comes into operational research, so you are basically operationalization is basically the process by which we take a meaningful but somewhat vague concept and turn it into a precise measurement. So we have an idea for what is going to happen, but then we address what we got into what we would like to achieve and what we need to achieve what we would like to achieve. So basically, we turn this into a measurement. And this is not just theory things, but there's some examples. For instance, age mean time since birth or time since conception. So it depends by if you are using if you are using age, for example, what is the length of time that you are going to use. What else? So operational means that, just to remind that there is no one true way to do something. And this is when it comes into research, is a challenging part. So because you are in charge for yourself, deciding what is the best things to do. And it might be, so the science, the data science scientist, it might be the data scientist which is in charge for doing this research, to address the research in a way that it will be able to answer the question. It's within these paragraphs, these sections, there are quite lots of examples, but basically, to summarize, you have a theoretical construction of what you are going to do, then you have some measures, and then you define the operations that you are going to make, and then finally define the variables that you are going to use. What else is important is that we have different types of measurements. So we are now defined our predictors, because they are predictors and response variables. So we are now defined those ones as a measurements, as we did, as I did it. As we did it, we defined the measurements, and they can be obviously nominal, and so categorical variables, and they can be of different types. They can be ordinal. They can be of an interval scale or a ratio scale. So I stop on this one because it's quite less mentioned within all the things that we usually do. So we know that a categorical, where is it? Nominal scale or categorical variable is a character, so such a bus, a car, a bicycle, in referring to, for example, if you do an example of transport type. So those measures of the transport type measurement are the nominal variable or categorical variables. When they can be ordered, they become ordinal variables. So the temperature set on a certain time. So, for example, temperature rising because of human activity. But these are other types. So an ordinal can be like, if I have a question that which answers, for example, I agree or disagree to something. So I have a scale from, let's do an example from 1 to 5, strongly disagree or strongly agree, and within this scale, so these values are ordered between 1 to 5, but they are categorical, but ordered. Then we have interval scale, and again, you might even temperature or ages. If you divide them into classes, they are sort of intervals. And then we have this ratio scale, and this is amount. For example, just to understand it practically, is the amount of time, for example, somebody takes to solve a problem or answer a question. So you basically adjust your so you have this on a ratio scale, basically, your variable on a ratio scale. And so nominal are obviously discrete variables, such as well as ordinal, and all of them, interval and ratio. But interval and ratio can be continuous as well if they have no gaps. So they cover all the possible intervals, or the ratio is from 0 to 1. So they are continuous, even if they are categorical. Okay. So what this can be tricky sometimes, but you understand what are you dealing with, and so think about what is it basically. If it's just a number, if it's an interval, if it's a word, if it's discrete or continuous. Continuous, in fact, as I said, it's continuous. So there is no gap. It's something that covers all the spaces within an interval of things. And you might experience some. This is what I mentioned. The how do you spell this? How do you pronounce this? Likert.
Right. Yeah. Likert scale.
Likert scale. And this is what I mentioned. So if you have a scale from 1 to 5, like strongly disagree, strongly agree, this, you know, you might have some discrepancies from the theories. So you adjust your answer based on what you would like to answer. So if, for example, you might not have 1 to 5, you might have 1 to 4, and you don't need strongly agree and just agree. So there's conventions, but there's even adjustment based on what. This is usually a 5-point scale, but it can obviously be adjusted based on so what is thought to be the best way to answer the question. In fact, they can be quasi-interval scale instead of just a scale. One more thing that need to be considered is so you now we are at the point that we answer, we know, so we are thinking about answering a question. We have a predictor, so the variable that with observed measurements, we want to see how it changes based on other variables within our set. They are assigned to be the predictors of our models and to answer the question. Then we have settled some adjustments to these measurements based on what we would like to achieve. And now we are at the point to verify if what we have done is good to go forward. And there are two elements that are mentioned. The reliability, okay, is the measurement going to be good? So how basically and you use the reliability and the validity, and for example, if you want, you need to think about how precisely you are measuring something, whereas the validity of a measure, it tells you how accurate the measure is. So you need to think about if you are going to be very precise measuring something, or how accurate is your measurement. Hi, Priyanka. That's okay.
Hey. Oh,
Hi.
I didn't realize I'm not on mute. Hi.
Hi. Okay, so we went a bit forward, but we are still at the very beginning of the chapter, so we go a bit faster. So what is the reliability? So you basically repeat consistently your measurements to see that you are doing precisely, you are going to do precisely what you want to measure. Okay, and an example which is nice says, why my mom's estimate of my intelligence is a bit unreliable. She might be right. Okay, so basically it's depend by who is doing the thing, and this is the challenge of making research, no? And it says, maybe I'm just not too bright, and so while her estimate of my intelligence fluctuates pretty widely from day to day, it's basically right. So it's personal somehow, but conventional thinking when you are about to define your reliability or unreliability of the measures that you are going to use. So think about how much is how and in the way can be even seen from another, of course. And what else? So there are different waves. So we are still here, not mentioning validity yet. So there are some test, retest, inter-rater and parallel forms, internal consistencies. Those are all, definitions that you can mention in the paper when you summarize what the things you do. What did you do? What did you use? Parallel forms or internal consistencies. What your answer is going to touch based on those things. And yeah, have you got any questions? Maybe. Are there any questions? Okay, and so now having set the measures, having set the question, having set the measure, having established what type of variables are we using, and define that if they are going to be good, there are some variables that are independent, other variables that are dependent. And so they are obviously outcomes and predictors. So when you assign those things, you might want to think about that not all the variables in your set will be used as a predictors. So you are going to left some part of your data aside because they are not useful for answering your question and sometimes can be confounding the answer. And so at this point, you think about, I'm going to do experimental research or not experimental research, because they are quite different and they have different outcomes. So if you do experimental research, you are testing new things on the data. If you are not experimental research, you are testing what you got. And if you make changes when you are doing not experimental research, that might lead to some extra not unwanted outcomes, because you are not, you shouldn't do that, basically. So mind within your research design what you are going to do. If you are doing experimental, you can make changes and add new things. If you are not experimental, you are not going to add new things. Okay, so here says that in the case of experimental research, you have, I've already mentioned all this. Basically, you are in control of all aspects of your study, and you can vary the predictors. So everything else is kept constant or is in some way balanced to ensure that they have no effect on results. So you are going to adjust and make changes on your to experimenting things. And you can do this with randomizations and so those things. Non-experimental research, any study in which the researcher does not have quite as much control as they do in an experiment. So you keep the things are there and don't add new things, don't change things. So you analyze the data and the things that you want. So that there can be quasi-experimental research or case studies. So you do case studies, you look at the case studies, how it is. For then the accuracy, you want to look at how your research can be considered as a valid piece of research. So can you trust the result of your study? And in this case, we talk about the accuracy. So in this case, we think about there are different type of validities that can be mentioned as well, or considered, like internal, external, construct, phase, or ecological validity. I'm not going through all of them because they are quite intuitive. So internal is causal, related to causal relationships between variables. External validity is to what extent do you expect to see the same pattern of result in real life as you saw in your study. So it's something that can be generalized. Then there is construct validity, phase validity, and ecological validity. So this is whether you are measuring what you want to be measuring. So it is constructive. It is something that is, and then whether the phase part of the validity is whether or not a measure looks like it's doing what it's supposed to be, is supposed to, and nothing more. So there are little differences, but they make difference in your paper when you mention it. And finally, the ecological validity gets into the environmental context of your research. So in order to be ecologically valid, the entire setup of the study should closely approximate the real world scenario that is being investigated. So it met, in that case, your research met the ecological validity. And so these are nice points to be mentioned in the summary of your paper research. Are there any questions? Okay, going forward, there are other things that need to be considered. And I've already mentioned those things because you need to think about if there's any confounding elements or artifacts that can be verified with your research results. And for example, confounds are a big concern for non-experimental studies, while artifactual results tend to be a concern for experimental studies more than for non-experimental studies. So this artifactual happening is a special situation that it might happen when testing the data in your study, while confounding it's an additional unmeasured variable. So you are not, okay, now you are not, you haven't used this variable, but if you use it, might change the result. So it's a confound. So you need to think about these elements, and even you need to think about the history effects. So you do a research question, but you start a certain point in time, but what are you analyzing? What you want to answer, and what's happened? Why are you there? What's happened before? So you need to sometimes history effects have an impact. So you need to look back at and think about why those things is as is when you start answering your question, and how things might change because you
I had one question on the confounding variable, Federica. So generally, or maybe it's theoretically true that it's an unmeasured variable, but like, don't we always, I mean, can we only not quantify the result of or impact of a confounding variable only when we have something, and then we, like, for example, mathematically speaking, you do this star this variable, right? So for example, gender or a country can, a categorical variable can be a confounding variable in many cases. So you would look at the impact, or, you maybe as part of your regression, you will make sure that whatever you're adding a confounding variable to ensure that it doesn't have an additional impact. I mean, isn't that true, or what's your thought on that?
Yeah, basically in this chapter is mentioned measure is mentioned, is defined as you have a vector of observed values, which is your response variable. And then this vector, and then you have some predictors, okay? All the variables that are the predictors are measures in, okay, so are defined in this chapter. And so the unmeasured variables are, in this context, are those variables that are not used within, so they are discarded. So you are not going to use it for answering your question because you have discarded. You have a sort, yeah, you know that, no? But in case you use it, they are not needed for answering your questions, okay, for example. But if you add them and you check your model, for example, with the stars and everything, that might be influential, the estimations, and so they are confounded. And you need to put some thoughts on that. We need to put some thoughts on that, because might they be useful? Can I include them or not? And so it's and you need to think about if they are confounders or artifacts. Because yeah, sometimes things can happen once, or sometimes it happens systematically.
Yes, I think so. Confounding variables are usually very special, and I think for me they're not very. It's not an easy process to always understand it, and I think of it as more or less confusing more than confounding. So that's how I sort of get it in my head. So you're looking at a relationship, right? Like, regression line of best fit or whatnot, and then when something doesn't seem right, and then you look at other variables, so there is this confounding or another variable that is confusing your actual sort of inference at that point. So something that can change, like additionally, which can change the results that you're seeing is the confounding variable. I somehow see it like that. And So I kind of very much relate confounding variable with a confusing one, because that's what it is doing, is if you don't take this into account, your results are very different.
Exactly.
Does anybody else also sort of resonate with that kind of understanding? Because that's the only way I have been able to, get that understanding in my head. Like, this is what a confounding variable represents. Right? You have anything to say? Okay. Yeah. Sorry, I cut you out.
Yeah, I think so too. I mean, I have to sometimes remember the idea behind the confounding variables, and that there could be something else that's contributing to the results, but and yeah, and so the results could be confusing to someone if you don't take that into account. Sure.
Yeah. For example, if you are studying, deaths increase because of heart attacks, and so you have some predictors such as smoking or not, or the age, the sex, or other alcohol consuming, or I don't know, like situation like those physical activities, that's physical activities. It depends what is effectively your answer. If you want to have ecological validity of your research, you think about the environment. You might use the physical activities, what type of physical activities, such as use the bicycle instead of going to gym. I'm doing those example there. It depends by the one you use it might change the result if you use it or you don't use it within your data. But if you use other data and you don't have this information, you might think physical activity, it doesn't, the increase or decrease of physical activity within time, it doesn't make any difference within heart attacks, possibility of dying of heart attacks. So, but it depends by you. This is the challenge of doing research. So it depends by you what are you answering, where you are going with this, what you are going to do, what do you want to achieve. And then if you do experimental research, you might want to add other information from external sources, for example, that might integrate your data. You might want to do resampling, randomizing data, and see what's happened, simulating other extra information. Or if you don't do experimental research, you just use your data. If you add things, things might change. And so those confounders are basically linked on the research question, the answer that you want to. Okay.
Sure.
Because,
yeah, that makes sense.
Yeah.
Thank you.
Okay, what else? So I said, think about the background of your data and what they can change, or they have, how they change it within time. Obviously, if you do, you can repeating, test repeating, and other things. And this comes to selection bias as well. So you need to think of many things, and be ready to answer questions based on your decision. Then there are some other effects that can be found on here maybe goes a bit to there are the first effect is homogeneous attrition, and the second effect is heterogeneous attrition. So if basically if you have an impact on all your data, or you have an impact on just a part of your data, so you might want to discard. For example, insulting people makes them act more obedient, in a more obedient way. You know, that can be valid under some condition, and might not in other conditions. So then there's always the things of thinking about if there's any loss due to missing data, missing information. And then so we finally reached the regression part. And then so the most common is the regression to the mean. This is what is usually the starting point, and then you might want to add changes to these things. Obviously, there might be some biases somehow, and this is basically what we can even have some other extra example, but I think I mentioned it, almost everything. So you can to reduce bias, to adjust your data, to look at overcome difficulties and everything. You can adjust your data, look at things that are not like outliers, things that are not useful, or if you have misinterpreted things, or you are, this is the example of the Simpson paradox, or things that might turn out differently for some reason that you are not aware of, or so might want to change something, your design, thinking about changing your data as well as making post, because you do a regression, first step, regression mean analysis, and then you look at the result to say, okay, this is a first step, what I can do, where I want to go, what I want to achieve, and then you might do post hoc, ad hoc hypothesis, and as well think about your publication. I've mentioned a bit of all those things, and adding things to reduce bias effect on publications helps. The more you explain to your audience, the less bias requests. So through questions you might receive, basically. Yeah, that's all I've got. And I mentioned that I mentioned that there is quite immense resource on this website, R4 Psychological Science. So, and this is there are core toolkits, many things working with data, many things statistics. So, and again, space for you know, doing other things. And even here, there is this experiment things, which is nice. So I'm not an expert about psychology research, but I'm sure that might be so things to think about.
All right. Thank you so much, Federica. I think this was a great discussion and just in time as well. So because I too have another meeting after this. But yeah, again, thank you so much. And I guess we'll call it a day for now and we'll all meet next week. Bye-bye. Bye, Ryan.
Good. Thanks,
Thank you,
Federica. Thanks, Federica.
See you.
Bye-bye.
Bye.